For the first time in human history, in late 2026, NASA is going to intentionally start a fire on the moon. Yeah, you heard it right. We have walked on the moon, we have driven rovers on it, and we have even hit golf balls across its craters. But we have never actually tested how fire behaves there. And NASA is so worried about exactly this because scientists suspect flames could be more dangerous there than on Earth. And today we are going to look at the terrifying physics of the space fires, also the harrowing real life disasters astronauts have already survived, including one incident that nearly killed an entire crew on the Mir space station. Now, to understand why it's such a massive threat to the upcoming lunar missions, that NASA has decided on this radical solution is lighting fire on the moon might be the only way to save the Artemis generation, and how results could literally make or break humanity's return to the lunar surface. Well, fire in space is fundamentally different from the fire on Earth, but the terrifying part is that you might not even be able to see the flames. Down here on Earth, fire behaves predictably. When you light a candle, the flame heats the surrounding gases. Because hot air is less dense, buoyancy takes over. The hot gas rise, creating a vacuum that pulls in the fresh oxygen-rich air from below and the flame shoots upward. This process is called convection and it gives earth flames their classic pointed teardrop shape and ensures they burn hot and fast. If the material is only barely flammable, the rising motion actually blows the flame right off. Scientists called it blow off and fire dies. Simple, right? But what happens when you take away the gravity? In the microgravity of the ISS, there is no buoyancy. Hot air doesn't rise because up simply doesn't exist. Without that convection current, the flame doesn't stretch out. It forms a slow pulsating spherical dome like a glowing jellyfish that can actually survive at much lower oxygen levels than on Earth. NASA's FLEX experiments on the ISS lit over 1500 tiny flames just to study this, and the videos are mesmerizing. Oxygen only reaches the fuel through diffusion, a slow but random bumping of molecules. Because of this, zero G fire burns cooler and slower. That sounds like a good thing, right? But it's wrong. The flow of hot gas is slower than on Earth, so the oxygen keeps feeding the flame steadily. Without strong currents that cause blow off, materials that would self extinguish here on Earth, they could keep burning for a dangerously long time up there. Because the combustion is slower and cooler, it's also incomplete. Also, instead of burning cleanly, zero G fires spew out massive amounts of toxic soot and deadly chemicals that could poison your system. And since there is no gravity to carry out the smoke away, the toxic cloud doesn't rise to the ceiling, it just spreads evenly through the cabin, lingering in the air and blinding the crew. The biggest danger isn't the heat, it's the chemical suffocation. To understand exactly how bad things can get, we have to look back to the 1997 aboard the Russian Mir space station. The 6 crew members were relaxing after a dinner when it was time to ignite a solid fuel oxygen generator, a routine chemical candle used to produce breathable air. They had done this 2500 times without issue, but this time a piece of latex globe from the manufacturing process was likely trapped inside. When the candle ignited, it triggered a thermal runaway. The aluminum casing melted and 3 foot jet of molten metal and orange fire blasted across the cabin like a blowtorch. Now, this wasn't a quiet, slow burning spherical space flame because the chemical candle generated its own oxygen. It burned fiercely, completely ignoring the vacuum of microgravity. The cabin immediately filled with thick, acrid smoke. The visibility dropped so fast the crew couldn't see their own hands. The jet of flames actively blocked the path to one of the Soyuz escape capsules, effectively trapping half the crew. It took the crew 15 agonizing minutes and 3 water-based fire extinguishers. If the fire had breached the station's hull, it would have been a game over. Thanks to the lessons learned from MIR, modern spacecrafts are already equipped with laser-based smoke detectors and ultra-fine water mist extinguishers. But as we prepare to send humans back to the moon, under the Artemis program, engineers are facing a terrifying new variable: partial gravity. The moon has about one-sixth of Earth's gravity, and scientists suspect that flames could actually be significantly more dangerous there than on Earth. Here's why. On Earth, the strong upward convection flow of air can actually blow a flame out if the material isn't highly flammable. Gravity helps to pull the heat away from the burning object. But in the moon's partial gravity, the airflow slows down. It enters a Goldilocks zone where there is just enough oxygen flowing in to continuously feed the fire. But the airflow isn't strong enough to carry the heat away or blow the flame out. On the moon, that heat may hang around and keep things burning much longer. Interestingly, a material that passes the fire safety test on Earth might burn uncontrollably on the lunar surface. Fire is ordinary until it isn't. That brings us to the FM2 mission, short for the flammability of materials on the moon. By late 2026, NASA plans to launch a self-contained combustion chamber to the lunar surface. Inside this box, they will systematically ignite 4 different solid fuel samples, equipped with high-definition cameras, radiometers, and oxygen sensors. This rig will record exactly how flames behave in lunar gravity over several minutes. We can simulate zero gravity fires in drop towers on Earth for a few seconds, but we cannot simulate continuous lunar gravity. The FM2 experiment will provide the very first bridge of hard observable data between Earth gravity fires and the zero gravity fires. This isn't just about blowing things up for science. The data from these moon fires will directly influence the design of future lunar habitats, rovers, and the very spacesuits the Artemis astronauts will wear. If an electrical short sparks a fire inside a lunar base, NASA needs to know exactly how flame will spread, how long it will burn, and how to put it out before it's too late. As we push the boundaries of space exploration, the environment becomes harsher. The physics become stranger. Mastering fire was the spark that started the human civilization on Earth. Now mastering fire in the void of space is the key to our survival among the stars. If you found this video fascinating, let me know in the comments. And would you volunteer for the first lunar firefighter? Also hit that like button, subscribe for more videos like this, and I will see you in the next one.